In this set of examples, we're only going to do three. This will be should be a short video. We're going to look at whether functions are bounded, and there's three ways something can be bounded. It can be bounded above, bounded below, or bounded. And you need to make sure you're clear on the understanding of what each of those means from the study guide, and we'll talk about that in the examples as well. And then we're also going to revisit maxima and minima. So let's go to number 36 first, and on number 36, the directions tell us to determine whether the function is bounded above, below, or bounded. So the first thing you want to do when you look at a function is think, do I know anything about this function just looking at it? And I know this is a function because, which means I can use function notation. If it's not a function, I can't use it. I see an x squared and no higher exponent, and nothing else happening. It's not inside a denominator or a numerator. It's just a straight polynomial. So that means this is a parabola. And furthermore, after what we've done for the last couple of weeks, I would hope that when you see a parabola from now on, especially when it has just an x squared, you would at least think of it the way I'm about to rewrite it. So the coefficient of x squared is -1, so I'm just going to stick that negative outside, and then I'm going to write this thing in vertex form. Remember, if there's nothing inside the x being squared, if it's just x being squared, that means there's nothing being added or subtracted, so I could write it as x plus 0 squared. And then that 2 out front is positive, so it's adding. Well, in this form, I can see that my vertex is 0, 2, and my a is -1. And that's really important to the question being asked here because it asks about boundedness. Boundedness is related to maximums and minimums. So this function, because it is an upside down parabola whose vertex sits at 0, 2, and I'm just kind of drawing it out in space. But see, I can just kind of think on paper, and it's just as good as a really nice graph if I'm thinking. And that's what you want to do to make all of this so much easier. So I now have an upside down parabola which peaks at 0, 2. So this one is bounded above because it has a maximum. That's how you know. It's bounded above at 0, 2. It's actually bounded at 2 because that's where the function stops. Its high point. That's that simple. So you shouldn't need a graph for that one. And in general, I would not expect you to need a graph or a calculator for one like this that's from a function we've spent a good bit of time talking about. Now, number 38, I gave you the graph because I will acknowledge, and these aren't gray bubble problems, which means that the authors expect you to probably pick up a calculator. But I'm trying to help you see that you don't always need a calculator, even when they tell you can use one. And that's the power of everything we've been studying. Number 38, we have y equals 2 to the negative x with the same set of directions. And I've given you the picture. You should recognize this as exponential, but in terms of thinking about it, even if you didn't have the graph, there's some ways you could know that. But let's just look at the graph we're given. Well, we've got this exponential graph, and here's my x-axis, here's my y-axis, roughly sketched. And then we have this graph coming down through, and let me do it from the other side. Because when you do an exponential, you should remember that it should come down and hug the x-axis, or whatever horizontal asymptote it's at. And you get a shape roughly like that. And this point in this graph is the point 0, 1. And if you think about it, that's because when I plug 0 in for the exponent, I have 2 to the 0, which is 1. So what I'm looking at is trying to figure out whether this is bounded. Well, it's not bounded above because the graph shoots straight up, which means it goes on up forever. And that would go up and out, but I kind of ran out of corner there to show you what I'm talking about. But it goes up forever, and then what happens when it goes down towards the x-axis is it flatlines. If you ever see a part of the graph going horizontal, it's bounded at that value. And so this one is trying to get to the x-axis, which is y equals 0. So this one is bounded below, and it's not at a point this time. But you would write the horizontal asymptote, which is bounded, because it's never going to be 0. Because remember, 2 to any power can never, there is no number to any power that can ever, there is no non-zero number, let me say it that way, to any power that can be zero. You can't turn a non-zero number into zero with an exponent, in other words. All right, let's look at 42, if I haven't completely confused you and made you turn the video off. All right, number 42 is a different set. It says use your graphing calculator to find all local maxima and minima and the values of x where they occur. Give the values rounded to 2 decimal places. So they give us this cubic function, and we graph it. And the first graph that you see in this little series of graphs is just the graph in the standard viewing window. One of the things you want to do on this set of problems is make sure that you are seeing all of the maxes and mins. So I would trust whatever you see in the standard viewing window, locate those, and then zoom out before you quit the problem to make sure you've gotten them all, or check your answer in the back of the book before you move on. But this is the whole story, because outside this window this function goes up forever and out forever, and later you'll know enough to be confident to say that without zooming out. But for now, use your zoom features to figure it out. All right, so first picture doesn't really tell us much because we need specific x and y values. Well, then in the next picture in the middle, I used my features on my calculator to locate the first point, which is a local maximum. And maxima and minima, in case I didn't reference that in the study guide, it's just plural for maximums and minimums. But we have this would be a local max, which I found using the calculate menu from the menu options. But then in the third picture, and I did it both ways just to show you it doesn't really matter. You just have to know what your calculator can do and how it does it. But this is what the Inspire will do for you when you're tracing. And this doesn't always work. I haven't quite figured out when it does and when it doesn't work. But notice that the little, what I call a flag here, if you pass any point of interest while you're tracing on an Inspire, that little flag pops up and tells you what's significant about the point, and that my calculator tells me that I have a minimum at this point. So just as a little recap before you grab your packets to look it up from your 1-1 study guide, if you have an 83 or an 84, or one of those families of calculators, remember your steps are the second button, and I believe it's the trace button, but what you're looking for above this button is calc. And then you'll, from that sub menu that comes up, you'll choose max or min, whichever one you're looking for. And then it will ask you for a left bound, and then you move your cursor over to the left of the maximum or minimum you want it to tell you about, and then you hit enter. And then you do right bound, same thing, hit enter. But on this one you hit enter twice because it asks you for a guess, which I don't really see the point of. But so you're going to hit enter twice, and then it'll tell you the answer on screen. If you have an Inspire, you just do, you go through your menu and choose your options. So let me make a note here. This is the Inspire folks I'm talking to here. It's menu, analyze graph is the option you're looking for. And then you're looking for either the max or the min, and you have to choose. It's not one; they're not on the same line, but you'll pick whichever one, and then it'll ask you for the lower bound. I think is what it calls it, lower and upper on the Inspire, and whether it calls it that on your Inspire, I think it may have to do with your operating system update or lack thereof. So we have a local min at. And what I would like for you to say, that these authors don't do this in the book, but again, this is my telling you how to write it so that it'll make more sense to you. We have a local min of negative 2.08 at x equals 1.15. We have a local max of 408 at, and that was supposed to be an at, my pen went crazy, at the x-coordinate, okay? X tells you where it happens, y tells you what happens there. And that's the end of this video.